Hello IT pros, welcome back to my IT workshop. So in this video, which is number 3 in the series, is subnetting based on number of hosts. So if you haven't watched the two previous videos, I encourage you to do so because we're going to be using information about them. I'm going to leave the link in the description below. So let's start. Subnet classes. As you can see, I have made this figure here, and we have 5 classes in IPv4, A, B, C, D, and E. But actually, we only use A, B, C. Okay, so the most important part to remember is the ranges and the default subnetwork mask for now. So the network bits, the host bits are important, but you get to use them when you actually do exercises. And the host per network. The most used one is class C, which has 254. That's the most used one anyway, depending on your needs, of course. So the ranges class A, B, and C, as you can see there, and the subnet mask are the most important things that you need to remember. That class A has a subnet mask of 8, class B 16, and class C 24. Right? So we are going to do exercises and we are going to understand this more in depth. So I'm working on a Windows computer right now. If I have open the CMD and issue ipconfig, ifconfig in Mac and Linux, it's going to give me my IP address. As you can see, it's underlined in yellow. So I have this IP address which corresponds, if we compare to the graphic, to class C, also the mask. So this is the IP address that my wireless router is giving me by default. Okay, normally that's what you get in a home environment. Okay, so let's continue. We have this IP address 172.10.12.34. That's a class B. Okay, because we have the graphic from a few minutes ago. So the default mask is going to be 255.255.0.0. So talking again of this IP address, the other way to represent this mask is this way, /16. These two are interchangeable. You can see this, both or one or the other in different books. So, but you have to know that they both exist. So what's subnetting? What's the main purpose of doing all this, and what it is needed? Is the process of breaking a big network into small subnetworks. Okay, so you might not need as many hosts that class B has, but you need less, and you can subnet that network. So that's the main objective of subnetting. So what can I use subnetting for? So to determine if a host is in a local subnet or in a remote network, when we do a reverse engineering to IP addresses, we're going to see why this is useful. And to create based on needs, how big, depending on how big your network must be. So these are the main important points for subnetting. So subnet calculations based on host. So this means that we're going to be calculating based on how many users, computers that we have. For this example, I created this small network, which has 3 departments in different floors: the legal, finance, and IT offices. So we are going to need 3 subnetworks for these different departments. So we are going to start with network 130.7.0.0, which correspond to class B, as mentioned in our graphic. And the objective is I need 30 hosts per network, only 30. You can need more, you can need less, but in this case, for this example, we're going to need 30. So the process of doing this kind of calculation, so we're going to follow a few steps. The first one is convert the number of hosts, 30, to binary and count how many bits we need to get the number. So we have done this in the first video, speaking binary. So I'm going to do it faster. We're not going to do through the calculation. So 30 in binary is equal to 11110. So the number of bits you can count them are 5, including the 0. Okay, so we need 5 bits to create the number 30 in binary. The second one is find the increment by converting the default subnet mask to binary. So what is the default subnet mask for a class B? We have seen in the graphic as well. That's why it's important to memorize that graphic. So the default network is 255.255.0.0 or /16. Okay, that's the default. We cannot change that. Well, actually we can, but we have to memorize that that's the default. So in binary, this mask is going to look like this. The first two octets are going to be ones, and the last two are going to be zeros. That's 255.255.0.0. Next, what am I creating? Networks, or am I allocating host? Well, for this video, we're allocating host, so that's the answer. That's why we need the 5 bits that we have found a few seconds ago. That's very important. So just a little explanation. We have this mask, 255.255.0.0. The underlying yellow part is the network portion, and the zeros are the host portion. Okay, so I'm going to represent it in binary like we did, all ones and zeros. And all the ones are going to be the network portion, and all the zeros are going to be the host portion of the subnetwork mask. These are the two parts that a subnetwork mask has. So all the ones are the network, and all the zeros are the host. So I'm going to reserve 5 bits from the host portion, which are already zeros, but I only need 5 bits. So starting from right to left, and all the rest, I don't really care what they are. I'm going to convert them to ones. All the zeros become ones, and the ones remain 1. So this is the very important step. Now, the first one after my reservation, well, I forgot something. My new network mask becomes 27, or 255.255.255.224. So where is the changing happening? Where's the increment? Is in octet number 4 that we learned in the first video as well. So the first one after my reserved zeros is my increment. In this case, is 32. The first one is going to be 128, the second 64, and the third is going to be 32. So this is going to become my increment. This is what I need to find my ranges for my IP, for my new subnetworks. So use the increment to find the network ranges. So as mentioned before, we're going to start calculating the ranges, the usable IP address that I can assign to every computer. So this is our IP address that we use for this example, 130.7.0.0, and where our increment is 32. So the increment, as I mentioned before, happens in the 4th octet. This is very important, okay? If it happened in the 3rd, well, we are going to use the 3rd, the change is going to be in the 3rd octet. But our changes happen for this example in the 4th octet. We only need 3 networks, since we have seen the diagram a few minutes ago, and we can have we are going to have more than 3 networks, more than 10 even. But for these examples, we only need 3. So the second ranges, these are the increments going to be from 32. So 32, 64, and 96. So the ranges are going to be, as you see here, from 0 to 130.7.0.31. Always a number before than the next subnetwork. So the next one, from 32 to 63, always a number before, and then the following is going to be to 64 to 95, always a number less. And the last one, well, we only need 3, but just to practice, is going to be to 96 to 127. Now we have a formula. 2 to the power of n minus 2 is the number of hosts per network, n being the number of bits that I need, that we calculated in this case is 5. Okay, so 2 to the power of 5 minus 2 is going to be 30. So that's the number of usable hosts I'm going to have per network. In this case, it's a coincidence. I choose it at random, this IP. So it's going to be exactly the number that we need. So why do we subtract 2? This is interesting. So in any IP address, the first number and the last number, we cannot use them. In this case, the first number in the range, the first range is 0. That's called the network ID. That's how the network is called. Like you are called John or any other number, that's what the network is called. You cannot use that one. And the last one in every subnetwork is the broadcast address. So the first one and the last one we cannot use them. Even if you put it with in an interface with, in this case, with this subnetwork mask, it's going to give you an error. So that's a rule. The first IP address and the last in a subnetwork, you cannot use it, never. Okay. So going back to our diagram, our little network, we're going to assign to the legal, finance, and IT departments the different IP addresses that we have found. For the first one, we're going to assign 130.7.0.0/27. For the second one, 130.7.0.32. That's are the names of the network. And for the last one, 6.64/27. So these are the IPs, the subnetworks we have found for those departments. Let's do another example. In this case, the class A 10.0.0.0, but this time we need 10 hosts per network. Okay, so we go to step number 1, convert 100 to binary. And for this is 1100.100. Those are 7 bits if you count them. And we need to remember this number for future reference. So step number 2 is going to be find the increment by converting the default subnet mask to binary. The default network mask for a class A is 255.0.0.0 or /8. If we convert this to binary, it's going to be the first octet is going to be ones and the rest is going to be 0. Okay, so I'm going to underline as we did in the last example, the network part and the host part. So the network part is underlined in yellow and the host part is underlined in brown. Well, network portion and host portion. Now, what's the next step? Is going to be what I'm creating. I'm creating networks or am I allocating host? Well, I am allocating host. So I'm going to reserve 7 bits starting from the right to left, or in this case, that's the way the software do it. But the rest are going to become ones. For this example, I only need to reserve 7 bits or 7 zeros. And as you can see, my increment happens to be again in the 4th octet. Okay, so my increment is 128. That's my increment. So let's find out about my ranges for this example. I know this part is very daunting. It took me like, when I learned the first time, it took me like 3 or 5 exercises to understand how to do it. So if you understand it, practice it. Now, the next step is my new network becomes 255.255.255.128. I believe I say 255 4 times, or /25. Okay, now I use the increment to find the network ranges. So let's put it, okay, we have 10.0.0, 10.00, then 128. But what happens when I add 128 plus 128? It becomes 256, right? Well, that's a mistake, because remember, in binary, in IPv4, each octet can only reach up to 255. We cannot exceed that. So when we have 256, it's like it cannot go any further. It's the maximum. It's 1 extra maximum. So what do? We don't have anything in the 4 octet. We have to go to the next octet. So that next octet becomes 1, right? So that's 0. So the next one is going to be 10.0 dot, you know the answer? .1.128. We're going to do one more so we can understand this. It's going to happen the same. 128 plus 128 is 256, but we have already maxed out our numbers, our limit. So it's going to become 2, and so on and so forth. So that happens when you have a number larger than 255 in an octet. It goes to the next number, to the next octet, to the previous in this case. Okay, so we have our network, and I'm going to do it here only the network, the usable IP address. So our network is in the first example, in the first subnetwork 10.0.0.0. So our range is going to be 10.0.0.1 usable IP addresses to 10.0.0.126, because 127 is the broadcast. We cannot use that, and 0 is the ID. For the second one, we go from 129 to 254, because 55 is again the broadcast, and the same for the third one. So if we go to our formula, it's going to be 2 to the power of 7 minus 2 is 128 minus 2, which is 126. So we have for each network 126 available IP addresses, usable IP addresses. As we have seen in the last example, the first one we cannot use it, and the second one and the last one we cannot use it, because in this case, and for the first, let's do it for the second one, 10.0.0.128. 128 is the name of the network. We cannot use that. We cannot use that one. So if we want to assign IP addresses to our host, our computers, servers, printers, laptops, iPads, iPhones, or whatever, or cell phones, we're going to start from 129 until 254, because 255 is the broadcast address. Okay, guys, I believe this video has been long enough and a little scary, but I encourage you to practice what we have done and do it on your own. So repetition makes you better every time. In the next video, I'm going to do 1 or 2 more exercises with a class C, so we can understand more how this works, and we're going to start doing subnetting based on number of networks. So instead of focusing on the number of hosts, we're going to focus on the number of how many networks do we actually need. Okay, thank you for watching this video. If you didn't subscribe to the channel, please consider doing so. If you like this video, please leave a like or a comment in the comment section below, and I'll see you in the next video. Bye bye.